Okay, this is going to be the last section in this unit, Unit 4. We're talking about interpreting the graph of a function. So previously we've talked about what a function is and different ways to tell whether or not something is a function. One of the ways is the vertical line test, and what that says is if we have a graph of something, any vertical line that we would draw through the graph can only touch it in one place. We also talked about how to tell on a set of ordered pairs, and the definition for that, or the rule for that, is that each x value can only have one y value. So our x value shouldn't repeat basically, because this 3 could only go to 6, this 5 could only go to 4. We can look at that on a t-chart as well. And the other way was a mapping, and that shows you how each element of the domain pairs up with each element of the range. Okay, so different ways to tell if something is a function or not. So now we're going to say we're looking at only functions, and we're going to look at the graphs of them and see what we can find out. Lots of different things we can find from the graph of a function. Okay, first of all, let's start with increasing. To tell if something is increasing, or to tell if the graph is increasing, that means reading it from left to right. From left to right, you have a positive slope. Another way to think of it is each y value is greater than the last y value. You guys know what increasing means. Decreasing then is going to be the opposite. So going from left to right, because we always read our graphs from left to right, there would be negative slope. And each y value is less than the last y value. And again, that is making sure you're going from left to right. The maximum is the y value of the highest point of your graph. The minimum is the y value of the lowest point on your graph. X-intercepts, we already know, are where the graph crosses the x-axis. And y-intercept is where the graph crosses the x-axis, or the y-axis. Notice for x-intercept, I put an S on it in parentheses because there could be more than one, but I did not do that for y-intercept. If you think about that, we're talking about a function. So I'm saying there could be more than one place where it crosses your x-axis, but there could not be more than one place where it crosses your y. I could not have a second y-intercept, because if I did, then I would not pass vertical line test. I would have 2 points on the same vertical line. So it's possible to have more than one x-intercept, but not more than one y-intercept for a function. And then average rate of change. Remember what rate of change means. Rate of change is just a different term for slope. Average rate of change is the slope between 2 points as if a line connected them. Okay? All right, and you'll see more what I mean with that average rate of change when we do the example here. All right, so here is a graph. First thing I want to talk about is where it is increasing. Okay, increasing. Well, remember what that means. It means you have to have a positive slope. And of course, we're reading our graph from left to right. So starting here, this is going down. It's decreasing there. Okay, so it's increasing from here over. So we could say that it's increasing from x equals 3, negative 3. Rewind, hold on. That's not the x value. What's the x value there? It's 0. From x equals 0 to, so you might be tempted to say x equals 6, but we have an arrow here, so that means our graph's going to continue on forever. So it's increasing from x equals 0 all the way to infinity. Okay, it's going to keep increasing. So it's decreasing from, read it left to right. This arrow goes on forever, so it's decreasing from negative infinity all the way to 0. We don't even have to put x equals. Whenever you're talking about increasing and decreasing, you're talking on your x axis. You're not looking at your y, so it's just your x numbers. So increasing and decreasing, maybe you could even jot that down back here. Increasing and decreasing, you're always talking about the x values that's happening on. Okay. I also want to show you different notation that we could use here. So when we're talking about the increasing, let's do that again. We already know it's from 0 to infinity. Another way you can write it is you can put your x in there, and we can say it's increasing when x is greater than 0. Okay, anywhere it's bigger than 0. All the way through when x is less than infinity. Okay, so putting that, if you think about this, think this through, it doesn't matter if we put this, because if we're saying x is greater than 0, we're not putting an endpoint on it. So we actually don't need to include this. We can simply say it's increasing when x is greater than 0. A third type of notation is to do interval notation, and we would use a parenthesis, and we would say from 0, it's increasing from 0 to infinity. Okay, so these are 3 different ways, 1, 2, 3 different ways that you can give your answer. This one is called interval notation because you're giving the interval on which it's happening. And this one is more of a set notation. Okay, let's do the same thing with decreasing now. So we already said it's from negative infinity to 0. While using an inequality, we could say that it's decreasing when x is less than 0. We don't include 0 like an equal to part either way, because that's where your change is happening. So you can't include it because on one side of it, it is increasing, one side it's decreasing. So at that point, it's doing neither. You cannot include it. In the interval notation, we would go from negative infinity to 0. Okay? All right. Minimum and maximums, I believe, are next. Yes. Okay, so let's start with a maximum value. Maximum values, remember, are the y's. So increasing and decreasing, we looked at x's. Maximums and minimums, we look at y's. So on here, what is the highest y value we go to? You might be tempted to say 3, right here and right here. However, keep in mind there's arrows on those. So that means it's going to keep going up there forever and ever. You're never going to have a maximum. It's never going to be one point. It's like, oh, yep, that's the top point. That never happens. So we would say there is no max. The minimum would be the lowest point, and we definitely do have one of those. Remember, we just need to give the y value. The y value, the lowest point, would be -3. So the minimum value is -3. Now you might have a question of where does that occur, and then you could give the x value. You could say it occurs at when x equals 0 or at 0, -3. But if you're just asked for the minimum or maximum value, you just give the y. All right, our intercepts. Your x-intercept, remember you could have more than one. Where does it cross your x-axis? Right here and right here. Okay, you only have to give your x values because we know every x-intercept has a y value of 0. So your x-intercepts are -3 and +3. Your y-intercept, there can only ever be one. You only need to give the y value because we know that x would always be 0, and that would be at -3. Okay, and then the last thing to talk about is that average rate of change. The average rate of change can only be found if you specify 2 points. Okay, so if I specified, let's go right here. Let's go from 0, -3 to 3, 0. Well, the average rate of change between them is the slope between 2 points as if a line connected them. Well, in this case, we have a line connecting them, so we don't even have to imagine anything. We have a line right there. So all you need to do is count your slope like you always have. So up 1, 2, 3, over 1, 2, 3. So your slope there, remember m is for slope, would be 3 over 3, but we always simplify, and that would just be a 1. Okay? Let's look at 2 different points, though. Let's go from -3, 0 to, oops, backwards, to 3, 0. Okay, so now I'm looking at these 2 black points. Now you might be thinking, okay, well first I am going down and then I'm going up. Well, but remember what your definition is. It's as if a line connected them. So let's imagine we have a line right here. A perfectly straight line, although mine's not perfectly straight. What is the slope of that line? It's a completely flat line. There's no rise to it, which means that slope is 0. Okay, so the average rate of change, you're looking at 2 points, connect them with a line, and just count the slope out. It doesn't matter if the graph of the line was there or not. This is just the average. And the reason is if you think about what an average is you add up all of the things, divide by how many there are. Well, if you look right here, this slope would be -1, negative, down 3, right 3. So this slope is -1. We already found that slope and said it was +1. They're the same length, so if you add these, -1 plus 1, you'd get 0. Divide by the 2 of them that we found, since they're the same length, they have the same amount, and you would end up with a slope of 0. Okay? So it's literally an average, but all you actually have to do is just count the slope on the straight line. All right, let's try another one. All right, increasing intervals on this one, and decreasing intervals. So let's just start from the beginning of our graph. So from -3 to -2, hopefully you can tell that's where it stops. You're decreasing. So let's write this, let's do interval notation on this one. So -3 to -2. And remember, we always use parentheses there. Okay, then from -2, keep going, keep going, keep going. Here's another change. From -2 to 0, we were increasing. And then at 0, from 0 to 1, we start decreasing. Okay? We put a little U sign in here, and that means we are just combining those. It's decreasing from here, and then union there. The maximum point, the highest point on your graph, the y value of it is 0, right there. The minimum, the lowest point on your graph, happens twice, and that's at -4. By the way, this open circle right here, that means you don't include that point. Okay, we remember that from graphing inequalities and things. Open circle means you don't include that point. X-intercepts, where does it cross your x-axis? Well, in this case, it doesn't actually cross, but it touches. This one, we don't include this point, so we can't say there, but right here at x equals 0, it does. And your y-intercept at y equals 0 as well. Okay, crosses over right there. Average rate of change from -2, -4 to 0, 0. Okay, you've got a little bit of a curved line, but we need to imagine it as if it was a completely straight line, and then just count your slope. Be careful, you're counting on your y's, you're counting in halves, and on your x's, you're counting by 1. So up 1, 2, 3, 4, over 1/2, 1, 1 1/2, 2. So we were up 4 over 2, which gives us a slope of +2. Okay, let's look at this one here. I'm going to have you guys find the stuff on this one. Hold on one second. Okay, so here's what I want you to find. Let's use this one. Let's use the notation with the less than and greater than symbols for your increasing and decreasing. Find all of the stuff, pause the video, and then we will come back and go over the answers. Okay, check it out. See if you got what I got. I do want to talk about this notation, make sure we got this right. So I just started from the left side of my graph, and I could see that I was decreasing through this point right here. So that would be x whenever x is less than 1, and that's going on forever. Then from here to here, I'm increasing. So that is when x is greater than 1, which is what this says, right? Just backwards. But also when x is less than 3. Another way to think of this is when x is between 1 and 3. I want you to write it like this. Make sure you write it like this. If you didn't do that originally, fix it up and do that now. Then from 3 to 4, we were decreasing. So again, it's that same type of notation. It's when x is greater than 3 and also when x is less than 4. In other words, when x is between 3 and 4. Be careful with that though. Don't write it like this. Okay, this notation would not mean the same thing. So you have to be careful with your less than, greater than signs to use the right one. It's going to be less than as long as you are in the order from increasing or from smallest number to largest number. If you want more explanation on that, come see me if you're confused with that. And then lastly, from 4 to infinity, you are increasing, so that goes back up there. So just read it from left to right, making sure you get every piece of the graph, so you're seeing whether it's increasing or decreasing on each section. Because you are continuing up in both directions, that means you have no maximum. You do have a minimum value right there, and of course that's your y value that you're giving. X-intercepts are 0.5 and 2, and your y-intercept is at 2.5. Average rate of change from 0.50, this black point, to 20, this black point. Well, if I had a straight line right there, there'd be a slope of 0, completely flat. All right, last thing in this section is finding function values from a graph. So we have previously done our function notation, where you would be given some type of function, and then they would ask you to find maybe f of 3. And remember, all we're doing is we are plugging 3 in for the x into the equation right there. So that would give you f of 3 equals 9 plus 1, which would be f of 3 equals 10. Okay, what I want to do is figure out how to find this answer looking at the graph of your function. So here's a graph. Whoops. It is the graph of g of x. And let's say we are asked to find g of 7. Well, if you remember what this value really represents, it's your x value, right? Okay, back here, when we were plugging in, we plugged that number in for the x's. So that is your x value. So that is telling you it's your input on your x-axis, go to 7, and figure out what the y value is. What's the output? In this case, it would just be 0. Okay, so it is simply saying here is your x. What would be the y value at that point? That's your answer. So g of, let's do -4. G of -4 means on your graph, go to x equals -4, and what's the y value? So at -4, well, I don't have a point right here. The point is right there from my graph. And what's the y value there? It's a 1. What about g of -7? So on your x-axis, go to -7, find your graph. What's the y value of that point? It would be 2. Okay, hopefully that's making sense. You're just finding the output at that input value. Okay, pause the video. You guys find these 5 values off of your function graph. Pause the video. Okay, so here's my outputs. Here's my function values at h of -6. So I went over -6 on my x-axis, found my point, and the y value was -5. So that's what I wrote. Did that for all of them. Check them out. Make sure you're getting them right. Okay, and then we have 2 questions that are from the FATE test, release questions from one of the old ones, one of the old tests. An equation of a function y of t is shown. So that doesn't always have to be an x in there, but we know it's still the input. So here's our equation, our function. Select all of the statements that are true about the graph of y of t for 6 is less than or equal to t is less than or equal to 8. So that's an interval they want us to look at on the graph. We don't have a graph, so use your graphing calculator to graph it. Okay, reminder on the graphing calculator. If you don't have one, you can use Desmos. You still need to do the graphing when I'm telling you to. So if you're at home and don't have it, go to desmos.com and do it from there. Okay, so I go to my graphing screen. I would clear anything out that was there, make sure I have a standard window, and then I press tab. Remember, this calculator is giving you function notation. This is saying f1 of x. This 1 is just indicating it's your first place to put it in, but you could arrow down and see, you could type in as many as you want, and that's just changing, saying here's your first function, second function, third function, etc. So we can just work in the first function spot. So y of t equals, we don't have to type because the calculator has f1 of x equals, which should mean the exact same thing. Type the rest of it though. Negative. Here we go. Negative. I need to use an x even if my variable is different. In the calculator, use an x. Squared plus 14x minus 40. Enter, and there's my graph. So I can't see it all that great, so I could zoom it, I could move it around. You can even just click and drag. I've shown you before how to do the zooming in and out, but if you just use this little touchpad part, and you can just click right there and move it around. Okay, so here's a pretty good view of it. I'm counting by ones, and they want us to look at the interval from 6 to 8. So from 1, 2, 3, 4, 5, 6. Let me see if I can write on it. 1, 2, 3. So from here to 8. Let me see, did I count that right? Okay. I could even find actual values. Let's do that. Let's plug in 6. Oh, and actually they're going to look at some 7s as well. But let's plug 6 in and actually do some function notation. So y of 6 equals negative 6 squared plus 14 times 6 minus 40. And then we're also going to find y of 7, since some of our questions are talking about 7s, and y of 8. Pause the video when you guys finish these. Tell me what the values of y of 6, 7, and 8 are. Okay, so using my calculator, I found my values of for 6, 7, and 8. Be careful here, don't square that negative. That negative is not part of the number you're plugging in. Now we could have pulled these values off of our graph, but for me it was hard for me to see exactly where they were. You could look at a table of these values. Let me get rid of my ink. To look at a table of values on the calculator, you would press menu, table, and then split screen table, and you could go through when we want to know when our x was 6, here's your y value, it's 8. When your x was 7, here's your y value, it's 9. When your x is 8, here's your y value, it was 8. So we actually did not have to go through and calculate. You could have used, your calculator is doing this for you, you could have used that table. If you want the table to go away, menu, table, remove table, or if you're on this part of it, menu, table, remove table. Okay, so there's 2 different ways you could find those values. You could pull them right off of your chart or right off of your graph if you can read them. For me, I felt like it was a little difficult. You could calculate them the way we did in the last section, or you could read them right off the table. Okay, all right, so now that we have all of this stuff, now let's figure out which answers. This is a select all, so there could be more than one correct answer that are true. The value of y of t increases over the interval. Remember, this just really means from 6 to 7. Okay, so going from 6 to 7, I'll erase my points. 1, 2, 3, 4, 5, 6. Here's 7. Okay, so going from 6 to 7, is it increasing? Absolutely. We went from 8 to 9. So yes, we could say that that is correct. Does the y value increase from 7 to 8? Well, obviously not. Whether you're looking at your graph or your y values, we went from 9 to 8, and we could see that on our graph we were from 8 to 9. We're decreasing, so definitely not that one. The average rate of change over the interval from 6 to 8 is 0. Well, if we could draw a straight line between those 2 points, it would be 0. Also notice that the y values were the same from 6 to 8. They were both 8s. So that means they would be a horizontal line, no slope to it, or no increasing or decreasing. So that means that one is correct. The value of y of t is constant over that interval. Definitely not. We went from 8 to 9 back to 8, so that can't be it. And the average rate of change over the interval from 6 to 7 is the same as the average rate of change from 7 to 8. So that's saying that this line would have the same slope as this line. And obviously that's not true because one is increasing and one is decreasing. So we have these, the first one and the third one, as our correct answers. Okay, last one. A function is shown. What's the minimum value of the function? Okay, so we would need to graph this. So back in our calculators, let me clear my ink out. I want to go and erase what I had. So menu, actions, delete all, menu 1, 4, enter. I want to go back to my standard window. So menu, window zoom, 5 for zoom standard, and then press tab. Here's my f1 of x equals. That's the same as f of x equals. So I will just start typing with the 5. Parenthesis, x minus 2, close your parenthesis, squared, and then plus 3. Here's my graph. They're asking for the minimum value. Remember, maximum and minimum values, you only need to give the y value. and I would say it is the bottom of that right there. That's the lowest point, and the y value looks to be 3. If you're not 100% sure what it is, your calculator will tell you menu, analyze graph, and right there, minimum. So same way when we found intersections, it wants you to do a lower bound. So somewhere to the left of that point, and then somewhere to the right. And as soon as you cross that, it comes up with it. Now it's going to give you the whole ordered pair, the 2, 3. Remember, we only want to give the y value. So the minimum value of the function is 3. Okay, that's all I got for you. Keep on working.